Hello student, today we will start paper 1, chapter number 2, Matrices of state pattern. Important topics of this chapter related are: first is elementary transformation. There are 6 total operations. We can apply 3 operations on the row and 3 operations on the column. So in this, first important rule is you can interchange any 2 rows or any 2 columns. Means Ri can be changed to Rj, या Rj can be changed into Ri. Means R1 can be changed to R2, R2 can be changed as a R1. Like this, you can change also columns. Ck can change to Ci and Ci change to Ck. Second important property is multiplication of the element of any rows or column by non-zero scalar. Means if you are given A is equal to 1, 2, 3, 4. Now you have to apply the operation on R2 is 4R2. Means you have to multiply R2 by 4. What is R1? This is your R1. This is your R2. Means in this operation R1 will remain the same, that is 1 and 2. You have to multiply only R2 by 4. So 3 4 ja 12 will come here, 4 4 ja 16 will come here. Okay. Now you have to apply only on the operation R2. Then again the new operation is C1 column. C1 changes to minus 3 into C1. What is C1? Here it is C1 and this is C2. Now I will multiply the element of C1 by minus 3. So I will get 1 into minus 3 and 3 into minus 3. C2 will remain the same, that is 2 and 4. Then A equivalence will give me minus 3, minus 9, 2 and 4. You understand? The third important property is adding any 2 scalar multiple of all the element of any 2 rows or column to the corresponding element of any other row or column. If A is given as matrix 2, minus 5, 3 and 1. The operation is given here is R1. The operation is on the row R1 is R1 plus 2R2. Means this is your R1, this is your R2. Okay. Now now the A equivalence will come to be 2 plus 2 into 3. R2 is 3 here. And R1 operation is minus 5, 2 plus into 1. And R2 will remain the same, 3 and 1. So 3 2 ja 6, 6 plus 2 is 8, 2 and ja 2, minus 5 is minus 3, 3 and 1. Now these are the important properties which are applicable in solving the problem of first exercise. In order to revise the 11th standard, you must know in 12th standard, that is identity matrix, that is 1 0 0 1 is the square matrix. Then rectangular matrix, a square matrix of 3 rows or 3 columns is 1 0 0 1 0 and 0 0 1. Upper triangular, second topic is upper triangular matrix या तो lower triangular matrix. Then in upper triangular matrix, this element must be 0. Means these 3 element must be 0 for the upper triangular. For lower triangular, this element must be 0. Yeah, so this element must be 0 by applying the row transformation, yeah, to column transformation, which is very useful for converting the given matrix into identity. Now we are going to solve the exercise number 2.1. The first problem is given A is equal to 1 0 minus 1 and 3. R1 changes to R2 implies R2 changes to R1. What is R1 is here 1 and 0. R2 elements are minus 1 and 3. Now A equivalence will come to be R2 elements take the place of R1 minus 1 and 3, and R1 takes the value of place of R2. So this will be your answer. Okay. Now we will go to the another problem. Second problem, B is given 1 minus 1 3, 2 5 and 4. Here the operation is taking place on R1 implies R1 minus R2. Means what is R1 here? Again R1 is here. This is R2. Means in this operation B equivalence. Okay. I will write down R2 as it is. Means 2, 5 and 4. Now I will apply the operation on only R1, that is 1 minus R1 minus R2, means R1 minus R2, means 1 minus 2 minus 1 minus 5, 3 minus 4. Now this will come to be, B equivalence will come to be minus 1 minus 6, again minus 1, 2, 5 and 4. This is the required answer. Okay. When the operation is given only R1, then R2 will remain the same, R1 will get changed. In the problem number 3, A is given as 5, 4, 1, 3. The operation is C1 changes to C2. What is C1 here? This is C1 and these are the C2 elements. So I will change. A equivalence will come out to be 4, 3, okay, and 5 and 1. This is my A equivalence. Second, B is given as 3, 1, 4, 5. Here the operation is given R1 changes to R2. Means R1, this is my R2. Okay. Now I will change this one. So B equivalence will come to be R1 changes to R2. Means 4, 5 and 3 and 1. Now the question is asked in this question is what do you observe? Means the matrices A is not equal to B matrices, but equivalence of A is equal to equivalence of B. You can write down equivalence of A equivalence is equal to B equivalence. This is the problem number 3. Means you have to apply only the operations which are given in the problem and decide whether they are equal or not. Now we will start problem number 4. In this problem, A is equal to given matrices 1 minus 1 3 2 1 0 3 3 1. The first operation on this is 3R3 and then you have to operate C3 plus 2C2. Okay. Now first I will apply the operation on that is 3R3. What is R3? R3 is this column. So this is the row of third row. I want to multiply by 3. So R1 and R2 will remain the same. Means 1 minus 1 and 3, 2, 1 and 0. Okay. Now I will multiply third row by 3. So 3 3 ja 9 will come here. 3 3 ja 9 will come here. 3 1 ja 3. Okay. This is the operation done on this given matrices. Now we are going to start C3 plus 2C2 on 3R3. What is 3R3? Is 1 minus 1 3 2 1 0 9 9 3. C3 is this. When this operation is taking place on only C3, so the C1 and C2 will remain the same. So I am writing this as 1 2 9 minus 1 1 and 9. Okay. Now on C3, what is the C3 is here? 3 plus 2 into C2. C2 is minus 1. Okay. Now in the second one is 0 plus 2 into 1 will come here. In third 3 plus 2 into 9 will come here. Now simplifying this one, I will get 1 minus 1, 3, 2 1 ja 2, means 3 minus 2 is 1, 2 will remain the same, 1, 2 1 ja 2, plus 0 is 2. Now this will be 9, 9 2 ja 18, 18 plus 3 is 21. This is the required answer for the given problem. Okay.